Okay, here we go.
Hello everyone, this is Rami, and today I'm gonna be going over the weekly paper review. And our topic for today is VR and AR, virtual reality and augmented reality. Uh, Before I start my paper here, I want to ask the class, what do you think about virtual reality technologies and augmented reality technologies, and how we could apply that in the construction industry? Do you have any thoughts? Like, do you have like any imagination or any experience?
I think one of the application is to view the future or the scheduled process in the next month or in the next like a year. We can just view them by using the VR.
Yes, that's a great answer. And some kind of this like opinion has been discussed in this paper. So we can like use these technologies to visualize the design and how we can improve our designs. Okay, so this paper was published in January 2020, and the topic is augmented and virtual reality in construction, drivers and limitation for the industry adoption. Uh, I'm going to start with the introduction. So this paper shows that virtual reality and augmented reality are visualization technologies that changes the way human interact with visual information, and also they are becoming widespread. Uh, and these technologies has been like identified as a top 10 grantor strategic technologies trend for 2019. But it's still the main application now in gaming and entertainment sector. The market for these technologies are estimated to be 94 billion by 2023. Many companies use these technologies for education, training purposes, and uh, Boeing reported that there has been 40% productivity improvement when they used these technologies to help workers using augmented reality mounted displays that support workers to enhance their work. Uh, Yet the level of digitalization index in the construction industry is still low, still the lowest of 22 industries. So as a background information, virtual reality was identified in this paper as technologies that enable creation of computer-generated environment that give user more sensation and being involved completely within a virtual environment. We can use head-mounted displays devices, and we can use it as a room-sized system. Augmented reality is a technology that enables overlay a digital information into a real environment uh, and in the correct to enhance the real environment. And we can use also head-mounted displays and handheld devices with a camera. And uh, as we said before, still like only 37% of construction companies had some experience with this kind of technologies. On the left side, we can see this figure. This is has been the definition like spectrum to identify the difference between virtual reality and augmented reality. This was proposed by Milligram in 1994 and still being used. As we can see, augmented reality is more to the real environment side, and virtual reality is on the virtual side. The table on the right side, we can see different type of devices that we can use to implement these technologies. There is augmented reality and virtual reality glasses, and like different devices that we can use. Also, there is some application. So this paper identified that augmented reality has been used more and virtual reality technology in the construction industry. Some of these applications, as we can see on the left side for the augmented reality, we can use it to see through opaque surfaces, so we can visualize the construction elements and the assets for the interface. Also, we can use it helping to find assets in the complex sites. So it gives like instructions to people like where things are located. Supporting design review, we can present augmented system, visualize the result of like different type of systems, supporting collaborative design and development of layouts. For the virtual reality, some literature reported that it has been used to also supporting the design reviews. So it's proposed like a method to support like constructability analysis meetings that use virtual reality to analyze the different type of methods based on BIM-based construction simulation. And also we can use it supporting immersive design and drafting. So for instance, it has been used in healthcare projects that we can like put the health workers in the virtual reality environment to see the design, and if there is like something that we can improve in the design to accommodate their needs. The motivation for this paper was because there is a great benefits we can get from these technologies, and also to mitigate the limitation for the adoption of these technologies and enhance the driving factors. So they do like identify, categorize, and rank the most relevant factors that limit and drive the adoption, and also provide clear and understanding the main factors that limit and drive the adoption of these technologies in the construction industry. Methodology for this paper was they used mixed research methods. So they do the qualitative data and then quantify that data. Qualitative data has been collected by using different type of workshops with experts, get the most factors that limit and drive adoption of these technologies, and then quantifies those factors by doing a questionnaire that has been sent to experts to see how they can rank and categorize those factors. And then they did scalability analysis and multivariative analysis to see how these results can be like used in research. Findings were from the qualitative method. They have like different factors that limit the adoptions, such as like lack of trained workers, limitation of size of models, and different type of limitations, and also some factors that drive the adoption, such as timely feedback, informed decision-making support. So there is like some factors that improve the adoption. After the analysis, they ranked 21 factors that limit the adoptions. The first ranked factor was the expensive hardware and training, specialized high processing equipment requirement, urgent to adopt new technologies. So they rank it from the high ranked factors to the lowest ranked factors that limit the adoption. And then they also identify 21 factors that drive the adoption of these technologies. The first one was a way to provide a new and better services. Virtual reality and AR improve the project understanding, increasing research and development investments in the construction sector, and reduces the overall risk and other factors that drive the adoption of these technologies. So from this research paper, we can see like there is a lot of factors that improve, and we can use it these technologies in the construction industry. So we need to limit uh, the factors that make people like don't use these technologies in the industry. And thank you. That's all. And this is the reference for the paper.
Thank you, Remy. Any question and comments from the class? Anybody? So quick question for you, Remy. You know, you
Yes.
mentioned that the paper mentioned a study using like some kind of a API to exchange data between BIM and VR. Are
Yes.
you aware of that work?
I'm not like fully aware about that because they mentioned that in the lit review. So they use these technologies in this kind of application, but
Yeah, that's us actually. It's
oh.
it's actually my paper. So anyway, thank you for mentioning that work. And originally I planned to talk about, you know, for the first half of today, originally what I was thinking about to talk about data analysis, the remainder of that. And the second half is VR AR. But since you already brought this topic, I guess I can just continue to talk about that. But before that, any question, comment from the class? If no, please use the link and put your evaluation for Remy. Thank you, Remy.
Thank you.
All right, like a side, you know, since Remy already brought this topic, let me just continue the discussion on this virtual reality and augmented reality applications in AEC. You guys can see the screen, right?
Yes, we can.
All right, great. Okay, so before that, you know, let me ask a quick question. How many of you have ever used VR or AR yourself?
Well, I used in PlayStation playing games, but not in other field.
Yeah, playing game is actually the #1 use of VR. Okay, so let's just talk about VR AR and how these technologies became popular about three, 4 years ago, and how the AEC industry, you know, talks about the use of VR AR in the future. So let's say, when was VR AR invented? Unlike a lot of people imagined, VR AR is actually a technology that has a long history. It is usually believed that, you know, it started in this 1968 by, let me see this, in 1968, and this Dr. Evan Sutherland from University of Utah, they developed the first ever computer rendered augmented or virtual environment. And at that time, the system actually took the entire room. As you can see, they had to remove some, you know, tiles, ceiling tiles, to have this infrastructure built. And the system, the device, the height, what do we call it, the HMD, the height mounted display, was so heavy, the user had to use the two hands to hold it while using that. But I think the reason we call this is the first generation VR is because the system can understand the motion of our head and render different angles of the virtual objects, which is the fundamental definition of virtual or augmented reality. And this is a video I found on YouTube showing the first head-mounted display of VR. As you can see, you had to use your two hands to hold it. and there's a lens, a look-through lens. You can move your body, move your hands. There are some IMU sensors built in, and to check, as you can see, this is a rendered cube, and the fundamental feature of this HMD virtual reality virtual environment is, when you move your head, when you look through the lens from different angles, ideally the virtual objects should be rendered in different way. Make sense? So to create that delusion that you're looking at something, and that the angles of that thing is changing while you're moving ahead, but everything is actually computation based. It's based on the graphic computation to track the XYZ and the rotation of your head and render the image accordingly. So that's 1968, 50 years ago, 52 years ago. So that's the first generation. Now let's check the current state of art. But I have to say, this is probably not current. I found this one on YouTube. This is work done about 4 years ago using the Unreal Engine. Unreal Engine is probably the #1 game engine for rendering VR because of the high quality of the renders. But for researchers, usually people prefer to use another game engine called Unity. But just check the quality of the current VR. Let me see if I'm sharing the audio as well. All right. What you're seeing is not a real building, just keep in mind. This is all computer-generated virtual content with all the features, the texture, the appearance, and the light reflection. Just imagine each of the light is some kind of mathematical formula in this, game engine, and it follows the physics rules in real world, of course, but everything is computation-based, is computer-generated. You see, you can define the feeling, the texture, the reflectivity of the different materials like wood, metal, clothes, and also later you can see also the reflection of mirrors. That's what we call game engine. Let me fast forward. And in the bathroom, you can definitely see the reflection of the mirror, and everything is so real until you don't see your own reflection in the mirror. You know something's wrong. There's a consulting company called Accenture, and Accenture actually published a report about 5 years ago, and their experts did some crazy mathematical analysis and say there's a 50% chance that we are actually living in a simulated world. You never know, right? I have to say, I started VR research about, in about 2014, so it's been six years. But I was still shocked when I first saw this video, this piece of work. I actually sent an email to the author of this model. I asked him, this is a guy from France. And I asked this guy, how long did it take you to build this model? I was expecting answers such as like 2 months, but he just told me like 4 days. You know, he was you know, I don't know his current status, but at that time he was a architect working for some company, and he said I have about 10-year experience building the rendered models. You know, you guys took my Beam class, you know what rendering means, right? So you have a model. Rendering means to make the model photorealistic, right? To generate the feeling, the texture, the reflection, everything. I decided I just enter into this Unreal game engine. I love it. And it took me just 2-3 months to know the functions of it. But everything else, a license learned from my previous work, like how to render a model. So it's more than it's not just how to use the program, but it's more about the feeling. Like I know how to assign the right color, how to assign the right texture, how to adjust the right parameters to show the proper reflection. So anyway, now I can see the big change moving from 1968, the first generation cube, to what we can have today, virtual reality. So this is like Remy mentioned, this is the most widely accepted definition called a Milgram chart or Milgram model, showing what we mean by virtual reality. So this is a spectrum. On one end, that's a real environment, the world we are living in. On the other hand, it's called a virtual environment. So what we have is, you know, moving from the real to the 100% simulated environment. The first stop is augmented reality. Okay, AR is, you can imagine AR is a look-through goggle that you can see the computer generated contents as well as the real world objects. So what you are seeing is just an overlay on the real world objects. For example, you wear this AR goggle like a Microsoft HoloLens or Magic Leap, and you still see the traffic, the cars, the buildings, but you can also see some floating chart in the air showing the information of the building or showing some kind of a cube floating in the air. So you see both things, the real world and the generated contents. That's called augmented reality. And on this end is a virtual environment or virtual reality. You know, people tend to use VE, virtual environment, and VR, virtual reality, interchangeably. So that anyway, they mean a 100% simulated world. So basically, you are wearing this goggle, but there's no look-through lens of this goggle. It's more kind of like a distorted screen in front of your eyeball, but with some built-in graphic card to generate the render picture. But you cannot see the real-world contents. You can only see the computer-generated contents. Milgram also mentioned something called augmented virtuality, AV. Although we tend not to use this term nowadays, but it still have a meaning. For example, HTC. HTC is one of the main vendors of VR today. They had this concept product about 2 years ago that you can easily switch if you want to see the real world or not. Make sense? So it's kind of like a button that if you don't like the real world, you click the button on, and then you can only see the isolated computer-generated world. But if you want, you can click the button off, then you can also see the real world. So it's easier for you to do that switch. But altogether, virtual reality, augmented reality, we call this thing mixed reality. You know, this is, you know, if you hear somebody showing talking about MR, keep in mind it's more kind of like a combination of virtual reality plus augmented reality, some kind of flexibility to move from the real world to a computer-generated world. So in terms of applications of VR, AR in this AEC industry in general, we are talking about the potentially big market. So for example, for real estate industry, the global market value is almost $1,000 billion. So think about the potential use of a VR. Home buyers, you know, especially for the luxuries, you know, I actually saw an article 3 years ago. There are some realtors in New York City. They are selling the luxurious apartments to their buyers, but those buyers, a lot of them are international buyers, and they just cannot come to the New York City to look to check the apartment in person. So they have this remote virtual reality model. They shape the VR goggle to the customers, the buyers, and then they can basically wear the goggle and see the apartment, and also mention and also adjust the decoration, as they want. So it's actually probably the first adopter of VR, as I observe, way before the construction industry start to talk about, or even the architecture industry start to talk about the application of a VR. Construction, in the U.S., construction represents a $1.2 trillion market. And so as we see later, we are talking about a risky and wasteful industry. So there are so many wastes in the construction industry due to the lack of communication. That's why building information modeling is becoming so popular, because it can enhance the communication across different parties. And of course, people start to see the application of VR and AR to improve the productivity and the communication in the construction industry. Facility management, that represents a $640 billion market in the US. So for this part, we start to see the emergence of AR, augmented reality, in this area. You guys probably have heard Microsoft HoloLens, right? So it's it's kind of like a big goggle with battery and a computer. You do not need to hook it up with some computer, because it itself is a standalone computer. It has CPU and a graphic card built in. And Microsoft now is selling the second generation of that, HoloLens 2. Military actually purchased 1 million units of that. And also they are selling this remote assistance package that you wear the AR goggle, and you can basically see the added information for your facilities. It's kind of like you're operating some kind of valve or electrical panel, and you see not only the panel, but also the information of that. And meanwhile, you can have a remote video chat with the expert, and you can see like a virtual hand doing things, and you can follow that thing. So AR, I have to say, for construction and facility management, AR is more popular than VR today, because we start to see the operational support potential of AR. We are, fundamentally speaking, construction is about changing the physical world, and we do need to see the physical world, and that's the definition of AR. So outlook in the industry 2020, when I got this data, it was 2 years ago, so it was called outlook, but now we're approaching the end of 2020. I'm not sure if the data still applies. But anyway, from the 2 year, from the previous projection, the number one user of VR, AR technology would be the video gaming, the gaming industry. That's for sure, right? Like Sony, like HTC and Oculus. Now it's called Facebook Oculus. Those are the three biggest VR, AR, not just VR, the three biggest VR producers today. And their number one customer is always gamers, video games. So about 1/3 of the market goes to the gaming industry. But you probably don't know, the second largest user is actually us, the construction and the real estate, industry. That's about 18% of the total market value, representing $6.3 billion market value. And healthcare, that's number 3. We're talking about hospitals, doctors, remote surgeries, right? And also we're talking about this video entertainment, like the streaming service, and potentially the movie, the VR movie concept, and also like a retail, education, and also military is start to talk about the use of AR. So why bother? Why AEC industry should care about this new visualization method? First, we have to keep in mind that AEC industry is a highly fragmented industry. We have so many parties. I think I talk about this, is something called the the lack of vertical integration. The biggest difference between us and the manufacturing industry is if you think about the Ford or GM, those bigger automaker, from the material supply to logistics to assembly to marketing, they are actually under the same name. They're actually under the same umbrella of a big company, a group company. So they already integrated different phases of their production inside of one process. But unfortunately, since each project, a construction project is different, each building is different, it's very difficult for us to have such a vertical integration. So we are talking about different parties in a project, like designers, engineers, general contractors, subcontractors, owners, and we are exchanging a lot of information, and also we are representing very different business interests and focus. So in general, this is very fragmented and the lack of organization. So according to this Building Smart report in 2013, about 50% of project cost can be estimated as waste. So if you're talking about a $1 million project, according to their survey data, about 500,000 can be avoided. That can be considered as waste due to the lack of communication. And about 30% could be saved with improved communication. So I have to correct myself. So 50% is the waste, but 30% can be saved. The other 20% waste is probably something can be hardly avoided. We know construction will generate waste. We know that, right? So if you have a drywall project, if you're pouring concrete, there's always physical, waste, right? But 30% of the waste should be and can be saved with improved communication. About 56% of product cost is put at risk by ineffective communications. What I mean is, yeah, I have $1 million project and I know 50% can be considered as waste, but still on top of that, there's a big chance of overrunning the cost. Did I show you guys the graph that is the survey data showing the percentage of project cost overrun? If not, I think I showed you guys, right? When I was talking about Monte Carlo simulation last time. Remember, I said there's a magical number of 25% overrun, and about 90% of projects are overrunning their cost, right?
Yeah. Yes.
Yeah.
Yes,
So,
I can remember this.
Yeah. So I guess people tend to have different explanations. This PMI survey, they say the overrun is driven by the ineffective communications. But my research shows, remember that it shows that because we are not using the right method to plan the product cost, we are just using the most likely to add the most likely. But if you run a simulation, mathematically speaking, you have to overrun your cost, right? I guess it's part of the ineffective communication, right? So because instead of showing just one number, we have to show the range to capture the uncertainty in the project. But anyway, 56% of product cost is put at risk because of ineffective communication. And 1/3 of product failures, that failure is more than financial failure, but it can also be safety issues, project certification, environmental sustainability, everything about the project quality, workmanship, and outcome can be, the failure of that can be attributed to the ineffective communications. All right, so communication, that's a big thing in the construction industry. And if you check, how this industry is changing by nature, other than the method change, I think the biggest change happening in our industry is the communication method change. So this is an old picture. It's called a studio. It's kind of like a factory at that time, to produce the drawings and project documents, construction documents, paper and pencil, right? And unfortunately, most scenarios today are still based on paper and pencils, right? So it's still a very ineffective method for communicating fairly complex spatial information. Think about this, guys. Jump outside of the box. Buildings, projects are 3D. Why are we still communicating in 2D? It doesn't make sense, right? But unfortunately, it's still the most popular approach. But unfortunately, we start to think about the way for better communication, like using VR to render the 3D model, but not only the 3D model, but you presenting inside the model to have the immersive view. Why this is important? Because we human beings need to feel the space. One thing is called, for example, one thing is called accessibility review. This is something like you build this facility, and from the paper, it's very difficult for you to imagine if you can reach a valve, if you can crawl in a space, until you see the space yourself. You get my point? When you see the space, now you can see, try to reach the valve, you start to see, oh, shoot, I cannot reach it. This is called accessibility review. It's the #1 use by a lot of design companies to use VR, because it's very difficult to imagine the spatial configuration, the spatial relationship, just based on the 2D paper, right? AR, this picture shows that, some companies start to use AR. This is a Microsoft HoloLens 1. You see the virtual bricks on top of the real bricks, so the workers know how to lay the bricks. So this is VR and AR use. And like I said, to me, the change of an industry is more than the physical methods, but it's also the information revolution in our industry. So the major milestones in our industry, like the invention of AutoCAD in the 1970s, the 3D CAD in 1990s, building information modeling around the new century, and the VR about 4 or 5 years ago. Every significant milestone means we are adding a bigger amount of information into the game, right? So 2D drawings, you can only see the geometry and the shapes, and all the other information will have to be delivered as a specification, which we call specs, right? And for the 3D, like a building information modeling, yes, it's a 3D geometry, but also you can add more what we call semantic information inside the model. This means, information about the material, the PSI, installation rate, supplier name, everything relevant to with that particular object, that relevant with that door, relevant with that steel column. That is called semantic information, can be inserted into your presentation, into your model. And now VR, AR, same thing. You add more information and we visualize that information in a very intuitive way. So I personally see the change of our industry is the change of information technology, okay, and potentially adding more information. So now let's talk about how this VR, AR can transform this AEC industry. Design. So how design happens, right? Basically, you have this idea of new project as an owner. You have this new idea. Like, for example, if you guys want to build a home and you hire this customer builder, do you know what is the current practice? The custom builder usually just say, hey, we have this type A, type B, type 3 buildings, pick one, right? Your involvement as the owner in the design process is very limited. So people propose this concept called co-design. They say the end user's inputs are the most important. Makes sense. I'm the user of this building. I'm the owner of this home. Why my ideas about how the floor plan should look like, where to put the windows, everything cannot be integrated in your type ABC design. But it's very difficult for the layman to do that, right? because they are not well trained. They can describe what they want, but they can never use the design language or engineering language to effectively communicate that. So we had to do several things. We're having several problems. Number one is making sense of project. This is the drawings we are always showing to the owner. There's no way for them to tell what's going on here. So we have to visualize the model, visualize the project, so they can better understand what do you mean. The problem with this difficulty for making sense of project include difficult to make a good decision for the owner, to affect the business opportunities, the certification, and also it will generate a lot of reworks, changes, and disputes. And we also know nowadays projects are often happen remotely. Like you have designers, engineers from California area, you're building something in New York City, but the owner is from China, for example. That's very common. It's very difficult to bring people together, and the teleconference, like a Zoom meeting, wouldn't help too much. So how to use this virtual reality, augmented reality to enable more effective, immersive teleoperation, teleconference, remote communication. That's also a very important topic today. And also how to coordinate design virtually. I can see you guys, I can meet you guys, we can share the ideas of the design, but we really want to touch something. If it can be something that floating in front of us and us can manipulate the same model, generate ideas. It's kind of like the children playing Lego game together. That would be more effective. So that's why my team started this virtual reality research. We try to solve the problems mentioned, how to make sure remote people can work together on the same design, how to make sense of a design much better to enhance the design. And this is an old video. I think it's from 5 years ago, but it's still a very interesting video. So as you can see here, we basically converted the building information model into VR. And we were probably one of the first few teams doing that. We work on BIM and we try to figure out a way to convert the BIM model directly to VR. We build this ugly laser gun, and this is a multi-user VR. And so actually people from different places can log into the VR model, and we try to figure out some way to point things. So we build this ugly laser gun to point things at that time. And of course, we had an iPad version. You can pick your avatar and you can work in this virtual building while you are in the real building. Of course, we had a phone version. So we were sharing the idea of the VR, to a lot of industry partners at the time. But you are talking to a bunch of gray-haired people. They are in their like 50s, 60s. They don't know how to touch the phone. They don't know. They were so embarrassed to touch the keyboard. So we really wanted to figure out an intuitive way to control the movement in VR. which we call HCI, human computer interaction. So we developed this interesting sensor. We bought this one. This is you guys know the game V, right? So this is actually V game. It's something dancing game, pad. You can dance on it, but we revised it. So then you just standing on top of that by leaning forward, leaning backward, or jump. You can control the movement of the avatar. Sorry. So I can see here, we were connected remotely and wirelessly in the same model. Three of us were connected remotely.
Can you hear me? Now follow me.
And also at that time, Zoom was not popular, and we built our own voice over IP communication method in the VR model. So it's kind of like the video chat in any video game.
This pointer? Yes, I can. Yes, I can.
And this is the paper you mentioned, Remy. We develop a real-time synchronization system that if a guy changes anything in the Rabbit model, the other person can see the changes immediately in VR. This is Rabbit. This is VR. Let's say I change the size of the TV stand. The data will be sent to VR and change immediately. And here we're just having fun, we linked the Google Doc to VR model. So if you change the number in Google Doc, you can change the VR view. Of course, you can use your phone to change Google Doc and to change VR. So for this work, the reason we are using Google Doc is very simple. We were very poor. We don't have any money to support the research. And we were trying to find a cloud server. The idea is very simple. You have a beam model here. You have VR server here. You need a cloud server. The server will read data every second from a beam model and send the changes to VR, right? So that's how it looks like. But we didn't have time to rent any server. Then we found a free server, very stable free server. I guess I said we, but it's actually I found that one. It's Google Doc. The idea is any computer programming is some kind of language, a computer language. And I think, Google Doc is a word editing software. It should be able to also edit computer program. So what we're thinking is we basically, create a Google Doc with IP address, and then we build a Java function inside that Google Doc. And this Google Doc will become some database plus program. It basically reads this beam model every second, like 10 times a second, and then send the updated data to the VR goggle. Actually, it's not send. The VR goggle will look for this particular IP address, the Google Doc's IP address, and then just read the data from the Google Doc. And then it's kind of like when you change Rabbit, the Google Doc will be changed, and then the VR goggle will read the changes from Google Doc and make that synchronization happen. And this is another video we had before showing that how VR can help with the design phase. This is the information panel. This is the information panel. It shows the information of whatever things they are looking at, and the information once again is directly from building information model. And you can walk by swinging your arms. You can pick up things, move them around. You can go upstairs, downstairs. And we simulate the physics rule, and so you basically can drop the TV. And also the water cup. All right, so that's the early works we have done, and we call this a multi-user system co-VR. Up to 100 concurrent users can log into our model at the same time. And we actually purchased the department, my previous department at Texas A&M, actually purchased 1,000 Google Cardboard. You guys know the Google Cardboard? It's a cheap version, VR system that can insert your phone into it and then turn your phone into VR. And we built the model, we share the model with the graduates. And so the students, if they want to visit the building, Francis Hall is the home of my previous department, they can just go to this particular IP address and use their phone. And it's kind of like a multi-user video game, and then they can see each other, talk to each other. You guys know this Google Cardboard? Let me see, Cardboard. That's how it looks like, right? So you just insert your phone there, and now your phone will be turned into a VR quickly. Like this is how you insert your phone there. And of course, we have other versions with butter plastic, but the idea is the same. Just turning your phone into this VR generator. You guys can definitely play with that.
I think we are seeing the PowerPoint.
Yes. Oh,
Okay.
you're seeing the PowerPoint. Oh, I see. Okay. I should share the entire screen instead of just PowerPoint. Now you see the Google Cardboard here.
Yes.
Right. So it's very cheap. $7-8. You have other version, more expensive, like $30. But it's this is Gear VR. You have to use the Samsung phone. But there are also other stuff like plastic. You can insert your phone there, and it's pretty good. It's becoming much better now. That's called the co-VR, at that time. And also the real-time synchronization, we call it SoVR, synchronization of VR, real-time design. So basically, you can change the type of objects, you can change dimension, you can move it around. And we are using, like I mentioned, Google Doc as the server. And this is how it looks like, right? So if you guys learned Beam before, there's something called a GUID, GUID. It's actually the ID for each component. So this is how our system works. We just have this cloud server to scan the metadata in your Revit model. And of course, we didn't mention the cloud server is Google Doc, but it is Google Doc. We build a function inside it. And then the game engine, game engine is a .exe file. We build this .exe file and burn it into the goggle. It's kind of like you open a video game in your goggle. And then a function, hidden function is that exe file will read this Google Doc 10 times a second to scan if anything changes. If yes, then I just make the change in this rendering. That's how it works. Yeah, and this is why Google Doc is useful. what you see as 3D objects in Revit, computer sees only numbers. Make sense? So this is something called metadata. It's just a description of the location of the object, the size of the object, the shape of the object. Then computer will translate the metadata into the 3D models. And then what we did is very simple. We just, send all this data into, you see this is actually a Google Doc, and just send everything to Google Doc. That's how it looks like. This is the data server look like. And then the VR exe, we just read this one. Of course, we know which number represents what. It's kind of like a line 15, column 3rd. That number represents the size of the column. Then check that number and render the column correspondingly. So we actually define the structure. I think the most difficult part at the time was how to parse the document, means where to find the right number from this mass, because when we read it, it looks like this. But we finally figured out the data structure used by Revit, and we actually made the system. So here's the thing. When we finished the multi-user VR, we wrote a paper. We sent the paper to a journal called Automation in Construction. It's a pretty good journal, right? But you guys know that the review of a paper usually takes 6 months. So we sent it in. When we sent it in, nobody was doing multi-user VR. After the first revision, we sent in our second revision. But during the second round review, a company announced that they made some multi-user VR product and selling that. And then when we received the second review comments, one of the reviewers said, "Hey, you guys are not doing anything new. Some company already announced this multi-user VR." So we basically send an email, send our rebuttal back and saying that that's because your review was so slow. When we sent it in, that company didn't mention that. So we are still new. It's just because of you. So we were so lucky we got accepted. Then we wrote another paper on this real-time synchronization of using Google Doc. Same story. After about 3-4 months, we sent in the paper. A company also developed their own like a synchronization product between Revit and the VR. And the reviewer also wanted to reject our paper, but we actually argued. It's all because your review was so slow. It took you 6 months to just give us your comment. We won, and we got the paper published. Yeah, this is how it looks like. Like you change the type of the chair, then in the VR, the type of the chair also changed. And here is a case you move the location of a concrete column in the design, and in real time, the column location is moved. Why is this important? If you're asking your owner, is that okay for me to move the column from here to here? It's probably very difficult for them to think about that. But unless they are sitting, standing in the building and see that and say, no, I don't want you to move the column. I think the column will block the traffic. This is why this real-time rendering and communication is so important. Of course, it's not just us. VR has been widely used today, to engage end users in the design, the co-design. Like for example, the McCarthy in the hospital design, they actually had a successful story in 2016. They invited the doctors and the nurses to engage in the design. Why? Because after the building is built, if they say, I just want you to move the bed a little bit, like the move the location of this bed a little bit, it would cost them $500,000. It's not just the bed, but also all the systems and device and everything connected to the bed, right? IKEA actually used VR in this kitchen design in 2016. Do you know why? Because they wanted to shrink the head of the designer to the size of a small child. And then they want to see how their kitchen design affect the experience of small child. That makes sense. What do you think? What do you see a good design might be a disaster to children, right? NASA is also using VR for their design, but of course they are not talking about structural design, but they are talking about their shuttle design, the panel design, like where to put the buttons. That's also part of the design. This is a Lockheed. Lockheed is the #1 contractor for DoD, and they have this collaborative human immersive laboratory, or CHILL, and they invite mechanical engineers, electrical engineers, structural engineers to log into the same model to design the engine and design their aircraft altogether. So this is actually a multi-user system. So that's the use of VR for design. How about for construction? We found this unique problem in construction is the visual spatial ability. This is something called isometric drawing or ISO drawing. It's very popular for MEP. Basically, for the pipeline, it's a 3D configuration, but we can only use a 45-degree line and 35-degree lines to show how the pipeline goes up and down, how it changes in the space. This means you have to be able to tell the orientation from this kind of a 2D drawing. That relies on something called a visual spatial ability. Unfortunately, not everybody has the same level of visual spatial ability. There's something called a cube test. So this is a standardized test to test your visual spatial ability. It basically, question is kind of like when this one rotates to this, this is how it rotates. As this one is rotated to what? This one can test how you can imagine 3D shapes from the 2D. Maybe you guys can try. If this one is rotated to this, then what this cube should be changed? A, B, C, D, E.
B.
B.
Do
you guys agree?
Counterclockwise.
I think this B. I agree. But it's not easy, right? So in fact, Goodram is a professor from Colorado State University. He is one of the first professors studying the use of a VR for construction. So he actually did a survey in 2016 and checked the cube test result of the construction workers, the visual spatial ability of construction workers. 3.5 is considered as an okay number. The score is from 1 to 5. 3.5 is considered as okay. But now you see the majority of the construction workers, I think it's more than 80% of the construction workers, their cube test result were lower than the 3.5. So it's dangerous for you just giving them this isometric drawing and hope the magic will happen, that they can figure out the 3D configuration by themselves. Howdy. So this is the new beam. So instead of using this isometric drawing, definitely we can use virtual reality or virtual environment. By the way, in terms of the VR method, we have the goggle, but we also have something called a cave system, computer-aided virtual environment. That's a big giant screen that you still feel immersive. This was my lab at Texas A&M, my old lab at A&M. We had this giant screen with 36 screens. Okay, with the VR function, as you can see, this part of the screen can show a very immersive third-person view, and this part of the screen shows the first-person view, and this screen actually shows the physiological information of the subject, such as heartbeat. So young. So this is the new beam cave. Yeah, we were having fun. You guys didn't know that. When I was teaching building information modeling at A&M, I taught that course in this beam cave. And we have that big, glass wall that if you turn it on, it becomes non-transparent. If turned off, it becomes transparent. So I recall, like for the game day, one of my students just say, "Professor, can you turn it on and let's check the game?" And I say, "Okay, let's do it." So actually, we watched the football game here, and that was good. And also, when I was teaching VR, I just put the VR game here, and everybody was having fun playing the game. Very interesting experience. This is a body motion tracking that we try to just use a couple of sensors, very cheap sensors called web tracker. Just 1, 2, 3, 2 on the feet, 1 on my belly, and this headset and 2 controller. With this 5 point or 6 points, we use something called inverse kinematics to recover my body pose. Because I'm a human being, if I know the motion of the certain points on the body, I can only move in certain way. It's based on human being, right? So we reproduce the body motion in VR because we believe this is important for us to do the accessibility review, like how I nail down and do some maintenance work. It depends on my body gesture. So we actually did that. Now I'm going into the body of this avatar. And here, as you can see, VR can also be used for construction safety like this one. We were doing this safety research. We want to see how VR can change your safety behavior. We designed this plank walk and a plank high-rise in the high-rise building, and we force you to go there to from one building to another. And we did experiment. I think it's on like 78 or 80 students. And for this one, as you can see, we also track the body motion, but this time we use something called the cont'd camera. It's a depth camera to track the skeleton of your body and to reproduce the motion of that. If there's no pandemic, definitely we would ask you guys to try it. It's so interesting, especially when you fell down. That's a cool experience. All right, and also VR for QA/QC. QA/QC means quality assurance, quality checking. We want to understand that will VR improve your memory, to put it simple. Like if you're a designer, you design something, but usually the actual building can deviate from your original design. But how you can be aware of that, how you build your memory about this building, how effectively, efficiently we can do it. So this is the previous, this is my previous department. So we created this VR model. We intentionally changed something, and like remove the location of the column, remove some of the windows, and we ask the students to work together as a team and see how much they can remember.
Getting twisted up on the darn thing. There we go. Cool. Thanks. Okay. Yeah, we definitely have not found 28 different discrepancies, but which all are original, but there's missing a door here. They're getting twisted up on the darn thing.
And also VR for training, flying the drone is very popular today, but the drones are also very dangerous and expensive. So we actually created this interesting VR system. We use a real drone controller to control the flight of a virtual drone. And meanwhile, this real drone controller can also control real drone. So imagine you are flying a virtual drone and a real drone together. And also the drone, this is Arduino, we started the development of Arduino, can pick your drone, calibrate the drone. Now you fly the drone and we simulate the physics of the drone, the virtual drone, as you will see, and also the iPad, the camera feed from the virtual drone to the virtual iPad will also be simulated. So it's just the experience looks exactly like flying a real drone. We simulate the physics of the drone. See the drone is actually turning and the tilting That's following exactly the physics of drone. Now we have a much better model, also showing the wind, rain, snow, and also the sound of the drone. Like if the drone is closer to you, you hear bigger sound. Now we have that kind of functions built in. We also work with first responders. We simulate different hazards like smoke, fire, explosion, and we see how VR can help them navigate in the space, and how can we better design the space to help emergency situation, like when people have to evacuate, what kind of design can help them better find the exits. We actually did a lot of work in that area. Okay, so let's stop here, take a break. Let's take a 15-minute break, and let's all return at around 5:35. Okay, see you guys then.